Welcome. We're excited to have everyone here today. I am Tara Moran, CEO of the California Water Data Consortium. And for those of you who may not be familiar with the California Water Data Consortium, we were founded in 2019 to support implementation of the Open and Transparent Water Data Act, sometimes referred to as AB 1755. And as all of you well know, data can and should be at the heart of informed water management here in California and beyond. And that really is at the heart of the vision for the consortium, which really is with active involvement from state agencies, NGOs, the private sector, tribes, academia, and many others to support the development and improved accessibility to high quality, trusted water data to support better outcomes for everyone living and working here in California. So the goal of our Data for Lunch series is to learn about new and innovative water-related data methods and technologies, but also to provide a venue to learn and connect with one another. And so we're absolutely thrilled to have Robin Grimm from Environmental Defense Fund and Forrest Melton with NASA Ames Cooperative for Research in Earth Science and Technology and with the California State University, Monterey Bay. So they're here to talk to us today about a relatively new technology called OpenET that Robin and Forrest have been spearheading in partnership with Google Earth Engine, the Desert Research Institute, and many others. So OpenET provides accurate estimates of field level evapotranspiration. And for those of you who may not be familiar with evapotranspiration, it's a critical component in water budgets in California and throughout the Western US. So having accurate and reliable estimates of evapotranspiration, or OpenET, provides the basis for more informed water management, including improved irrigation and crop management, sustainable groundwater management, the development of water accounting and trading tools, and a host of other management decisions. So really excited to have them here today and learn more about the technology and some of its potential applications. I'm also excited to introduce Christina Babbitt, who will be formally introducing our speakers today. Christina is one of the consortium's steering committee members and a senior manager with the California Groundwater Program at Environmental Defense Fund. And so before I hand things over to Christina to do the formal introductions, I just wanted to touch on a couple of housekeeping items. Firstly, our next Data for Lunch is scheduled for May 21st from noon to 1 with a 30-minute sort of less formal discussion period after, similar to today. This presentation will be with Heather Krause from We All Count, and she will be speaking about a data equity framework that We All Count has developed. So looking forward to that one. We hope you can all join. If you have other suggestions for other Data for Lunch topics, please reach out to either myself or Amanda Miller, and I will go ahead and drop our emails in the chat window in just a second here. And then just a quick overview of the structure of today's meeting. After Christina does introductions, we'll hand things off to Robin and Forrest to give a sort of 25-minute to half-hour presentation. We'll have time for questions after that, which Christina and I will moderate. So if you have questions, please drop them into the chat. Be sure to include your name and affiliation. And we're also going to try something slightly different from the approach that we did last time and allow some of you to come off of mute and ask questions yourself, just so that we can bring some other voices into the mix. So please raise your electronic hand, which can be done using the reactions tab at the base of your Zoom screen. And we'll be using those to track questions along with tracking in the chat window. Similar to our last event, we have Robin, who is going to stay on after, and we'll have this sort of less formal discussion from 1 to 1:30 following the sort of more formal presentation and Q&A. And then I mentioned this previously, but Robin and Forrest have agreed to share their slides. So we'll have both the recording available through our website as well as a downloadable version of their PowerPoint presentation. So looking forward to hearing from them. So with that, I'm going to hand things over to Christina.
Perfect. Thank you, Tara. Good afternoon. I'm really excited to join Tara today in welcoming all of you to the collaborative second Data for Lunch Brown Bag series. And I'm particularly pleased to introduce Dr. Robin Grimm and Forrest Melton as today's speaker. You have Robin and Forrest's bio in your meeting invite, so my introductions will be relatively brief. First, Robin, she is a senior manager of water information systems at Environmental Defense Fund, where I have the great privilege of working with her. Robin serves as the OpenET project manager, and she leads on the ground implementation, coordination, and development of the project, which is quite a big project, as you'll see when they begin their talk. Robin has over 10 years of experience working on water management and policy in California, including expertise on levee policy for the Sacramento-San Joaquin Delta and on multi-objective management for the Yolo bypass. We're also privileged to have Forrest with us. Forrest is a senior research scientist with the NASA Ames Cooperative for Research in Earth Science and Technology and with California State University, Monterey Bay. Forrest co-leads the OpenET technical team, and he serves as the primary coordinator of the ET modeling teams. He has received numerous awards for his work to develop applications of satellite data for water managers and agricultural producers in California. And we're so happy to have both Robin and Forrest here today. So thank you all for taking the time to join us. And with that, I'll turn the virtual floor over to them.
Thanks so much, Christina, and thanks to all of you. I see some familiar names, but lots of new ones. In all cases, really appreciate you spending the time with us today. So I'm going to go through a set of slides here, and I'll count on others to let me know if there's some urgent questions. I welcome interruptions if there are, and look forward to the discussion at the end. Probably not news to you, and Tara did a great job of sort of going through some of the opening points I usually make on this, but thousands of people every day are making decisions about water, from farmers to local and regional water managers, all the way up through state and federal planners. And with water supplies becoming increasingly scarce, a lot of those folks are being asked to do more with less, which just makes good data for decision making all the more important. But a really important piece of information for water management, which is knowledge or understanding of the amount of water that's consumed by crops and other vegetation as they grow, has been lacking in terms of a consistent source for timely data on that particular variable. So OpenET aims to fill that huge data gap, and for the past 3 or 4 years now, actually, scientists from NASA, Environmental Defense Fund, the Desert Research Institute, USGS, and the USDA have all been working in partnership with Google Earth Engine, several university partners, and dozens of stakeholders on OpenET, which is a web application that aims to enable improved water management in the Western US by providing field scale evapotranspiration data across 17 Western states initially, eventually expanding to include the entirety of the US within a couple of years or even sooner. So evapotranspiration, for those who aren't familiar with the term, as Tara mentioned, it's the process by which water evaporates from the land surface and transpires from plants. It's actually the second largest component of the water cycle, and in some ways can be thought of as the opposite of precipitation, in that it's water that leaves the land surface and goes back to the atmosphere. And as such, it's water that's really lost to a local system after being applied to the landscape. So while some water may recharge a groundwater basin or run off to a local stream, which are the third and fourth bullets there in front of you, the water that evaporates or transpires, that water is effectively gone, right? So managing water without ET data is like trying to balance a checking account or a checkbook without really knowing how much is being spent every day. There's multiple ways to generate estimates of ET, and in fact, they've been refined over several decades of research, but the estimates from different approaches can differ, and sometimes those differences are large. And the data then ends up being fragmented. So it's generated by different approaches on a case-by-case basis, and only by those with the technological or financial capability to afford them, which can lead to confusion and lack of trust in the data, along with that access barrier that keeps it out of the hands of many who could really stand to benefit from its availability. So OpenET is really aiming to address both those challenges, making the data more broadly accessible, and also making it more sort of commonly understood by folks who really need to use it. OpenET uses publicly available data from multiple satellites and weather stations and the Google Earth Engine platform, and brings together several of the more commonly utilized approaches for calculating ET onto a single platform for the first time. So we've brought the scientific community behind those different ET approaches together, and we're using best available science to make consistent, near real-time, field-scale ET data easily accessible for the Western US. So this summer, you'll see a demo in a little bit, but quick screenshot here is a peek. When OpenET goes live, anyone will be able to go to a website that'll look much like this image, zoom in on any geographic region in the 17 Western states, and get near real-time ET data for that particular location. There's a lot of really exciting potential applications for OpenET. The first is that it allows for the development of more realistic water budgets so that decisions about allocations in a basin or watershed are based on a clear, timely understanding of current and historical uses. It also enables local water managers to develop incentive-driven conservation programs that are driven by real data and can really properly credit participants for changes in water use. Similarly, the ability to track water use in near real time can significantly reduce transaction costs for water trading programs. And finally, there's applications of ET data at the field scale where ET data can be incorporated into ranch management or other irrigation management software to help maximize crop per drop and reduce costs for farmers. The project from the outset has been driven by three primary goals. The first of those is the most self-evident, right? That we're looking to make reliable and easily accessible ET data available via a website. But we also are really emphasizing the importance of trust in the data. We know it's only useful to the extent that it's trusted and actually taken up and used in real applications. And so we're really emphasizing partnerships and sort of building ownership and trust in the tool at all levels of decision making, from the very local all the way up through state and federal levels of decision making. And then finally, our hope is that the two of those in combination will lead to a variety of sustainable resource management practices being enabled at a scale that just wouldn't be possible without easy access to data like this. So in terms of that second component, the trust component, as I mentioned, we really prioritize engagement with end user communities from the start. We worked with over 100 farmers, practitioners, water managers, and state and federal planners to help guide and test development. One of the first things that the team did actually was interview a lot of partners and develop a use requirements report that then has formed the basis of the platform's design. And we've iterated with those folks over the past couple of years. They've tested the beta version of the site for us. And just provided really invaluable feedback throughout the process. Forrest will speak to this in a little bit, but the other part of sort of building trust in this is just the fact that we've brought together so many really important leaders in the scientific community behind these methods and approaches for generating ET estimates, and they're working really hard to ensure the integrity of the data. And again, Forrest will speak a little bit more to that. So one of the ways that we've worked with stakeholders is by engaging in these use case partnerships. The map here shows that we've tried really hard to ensure that they sort of capture a wide variety of applications, both in type and also in scale. So working with folks who are managing water at the really local level, all the way up through partnerships with the US Bureau of Reclamation. I wanted to put the map here just to give you a sense of scale and diversity of uses that are captured by these use cases. I think it's more interesting to talk about them in the context of the demo. So Forrest is going to go into a little bit of detail on a few of these. But if there's any particular name on here that sort of captures the interest and somebody wants to learn more about any one of these particular use cases, feel free to ask a question and we can come back to it. We also recognize that use cases are time intensive and require a lot of team capacity. And so we wouldn't be able to capture all of the perspectives that we would want to have informing us with just those use case partnerships. So we also put together these working groups. You can see we also, again, tried to capture a range of perspectives. And this working group has also helped us sort of increase awareness about the platform and the fact that it will be available later this year. And we've had about quarterly interactions with these folks where we've brought them questions about functionality or context or a whole host of other communications, other issues that we're working through, and gotten really valuable feedback. So I saw some names on the attendees list here of folks that are on those groups. And to those of you who've been helping us, thank you so much. We've gotten some early signaling that some of the trust building that we've worked so hard on has started to pay off, in the sense that there's folks across the sort of spectrum of those who are involved in water who are excited and enthusiastic about OpenET. And you can see supportive quotes from a few of those on the slide here today. We're really excited and motivated by the fact that people, at all levels of decision making across the spectrum are excited about this tool. So that's a really rewarding aspect of working on this project. I'm going to pass it over to Forrest now, talk a little bit more about the technical details and the team that stands behind it.
Thanks so much, Robin. As Robin mentioned, one of the challenges previously for working with remotely sensed evapotranspiration data was the fact that it was available from different approaches and different sources, especially at local scales. And so one of the things we've done through OpenET, and in large part thanks to the support from our philanthropic partners, is we've been able to bring together many of the leading experts in the US on remote sensing of evapotranspiration to work together on this effort. And so when we began this effort, there were 6 different satellite-based ET models that were advancing towards, well, either in use operationally or advancing towards operational use by a state or federal agency in the West. And we brought the teams that were developing those models together to work on implementing a common operational solution, and from these different approaches, calculating a single ensemble value that would represent the scientific consensus on the best estimate we can provide for any time period and location. And so in total now we have a team working together from 3 federal agencies, 6, 7 universities now, EDF, Habitat 7, and Google Earth Engine. So a really nice example, I think, of a successful public-private partnership to solve what's been a long-standing technical challenge in water data and water information. At a really high level, this is a schematic for the key components of the OpenET architecture. What I want to emphasize is that OpenET is driven entirely with publicly available data. So the models are driven with publicly available satellite data from NASA, USGS, the European Space Agency, and NOAA. We use gridded meteorological data sets as additional inputs to those models. The models are being implemented as open source software on Google's Earth Engine platform, which was developed specifically to support applications of Earth observation data and high performance computing to address these types of challenges. The models are then summarized for millions of field boundaries across the Western US using publicly available field boundaries from state and federal agencies. Those results are then stored in a geodatabase, and they can be accessed both through the user interface, which we'll show you in just a moment, through the Data Explorer, as well as through an application programming interface or API. And we developed the API in particular because we understand that for many applications, ET data is most valuable when it can be combined with other sources of information, especially at the field scale. ET is an important input into irrigation scheduling and management, but it's one of more than a dozen factors. The irrigators have to account for not only the irrigation system type and application rate, but distribution uniformity, factors related to salinity management, the leaching fraction, soil texture, timing and availability of water, on and on and on. And so our approach for those applications is to ensure that information from OpenET can be integrated into existing farm and ranch management software tools, whether those are tools like CropManage being developed by the University of California Agricultural and Natural Resources Institute, or tools being developed by the commercial sector. In addition, we want the API to facilitate retrieval and ingestion into local, state, and federal water data information systems, and to support use in water trading and water accounting platforms, such as one of the use cases, which I'll talk about in just a moment. These are the different satellite-based ET models that are currently part of OpenET. I'm guessing some of these are familiar to you. Again, they represent models that were being developed by USDA, USGS, NASA, as well as models that have been like EEmetric and CBAL that have been previously used both by state agencies and consultants for water resources management at local scales across the Western US. One thing I think that's really unique about OpenET is the ability to bring together a community. I think the current funding models for science have a lot of strengths. There are many advantages to a competitive approach to science. But when it comes time to develop a national system, there's a lot of value in bringing a community together to work together collaboratively. And what we've seen is that bringing together this team has allowed us not only to make improvements to the consistency of the inputs, the satellite and meteorological inputs that drive these models and the pre-processing routines, but also to start to compare models at scale and understand where there are similarities and differences, and take advantage of those comparisons to make improvements to the individual methods. This in return has, as a result, has reduced some of the current discrepancies among different approaches and improved consistency of the ET estimates across the suite of models, the ensemble of models. It's also allowed the team to collaborate on what's now the largest intercomparison and accuracy assessment ever conducted for remotely sensed ET data, and helped us bring together a much larger pool of ground-based measurements than any single team would have been able to compile and process. And to say a little bit more about the intercomparison and accuracy assessment, the primary data set we're using currently are these flux tower measurements collected both in agricultural fields and in natural ecosystems across the US. We've compiled more than, well, getting close to 192, so almost 200 flux tower data records from across the US. Many of these are from agricultural landscapes, irrigated agriculture, rangelands, rain-fed agriculture. What we're doing is we've taken about 40% of these sites and we're conducting an open phase 1 intercomparison for the different models. This is the first time many of the models have been implemented in a fully automated system and run at scale across the Western US. So we are conducting this first phase 1 assessment to allow the teams to identify any systematic errors or bugs in the implementation on Earth Engine. And then we're holding back 130 flux tower sites, about 60% of our total data record for use as a phase 2 blind intercomparison. And we've completed phase 1. I'll share the highlights with you here on the next slide. And then we're currently working on phase 2 on that blind intercomparison and accuracy assessment. We will use the results, the phase 2 results, to inform calculation of the final ensemble value. Currently, we're calculating the ensemble value simply as the mean across all models. For phase 1, we had 5 models available. And even just using the mean, the results I thought were highly encouraging, especially for cropland sites. Tables at the bottom summarize key accuracy metrics, both for the monthly and daily data values. We're focusing on slope, mean absolute error, root mean square, and the R-squared value as a measure of the degree to which the model captures the observed variability in the flux tower data record. And so we're seeing the slope, especially at a monthly time step, near 1 for most of the models, ensemble mean slope of 0.97, very low bias. We were really encouraged by this. Error metrics, mean absolute error, root mean square, on the order of 0.5 millimeter to 1 millimeter per day. We expect that to decrease even a little bit further as a result of the phase 2. And once we implement the final version of all models and have addressed some of the systematic issues in a couple of the models. And then R-squared values, again, pretty close to 1, 0.94 at a monthly time step, 0.89 for the ensemble at a daily time step. So really encouraged by these initial results. And importantly, one observation is that the ensemble mean, that ensemble value, performs as well or better than any individual model across almost all the sites and all the accuracy metrics we've looked at. The two really quick, I want to say a little bit about the 2 figures at the top. Figure 1, these are for, we had from our phase 1 cropland sites, we had 15 sites that had a full data record for at least 1 growing season. And so figure 1 is comparing the average estimated ET for the growing season from each model against the flux tower data record. And what we can see is across those 15 sites, all models were within plus or minus 6% of the flux tower ET, the average flux tower ET, and the ensemble mean was within 1%. So really encouraged by those results. In addition, we can look at the relationship, for those of you who are familiar with this technique, we can look at the range between the unclosed flux tower, that direct measurement from a 3D sonic infrared and infrared gas analyzer, and a closed flux tower, flux tower that's been corrected for energy balance closure. And we can see that all the models are falling either within that range or within plus or minus 6% of the closed energy balance. Looking at the results for a full year, we had 10 of the flux tower sites which had at least one complete year in the data record. And we could see that all models were within plus or minus 9% for the closed flux tower ET. So again, really encouraged by these phase 1 results, meeting or exceeding our initial accuracy targets from our partners, and looking forward to completing the phase 2 results. Next slide. Key milestones for the next few months here. Most important one is we are targeting our public launch for the end of July this summer. As we're working towards that, key milestones are completing our intercomparison and accuracy assessment to calculate that final ensemble value for each time step and location, developing a number of pages to help with outreach and education, as well as a best practices manual describing recommended applications of OpenET data and selection, in some cases, of particular models or subsets of the full ensemble for specific water resource management applications at field to basin scales. Working on a communication strategy in anticipation of that public launch at the end of July. And then after that, we'll be focusing on ongoing outreach and training workshops, standing up a nonprofit to serve as the long-term home for OpenET, and then working towards the launch of the application programming interface and a custom reporting interface to allow folks to calculate custom summaries from the OpenET data. I should mention that the API is built on the Open API standard, and we're doing our best to follow a lot of the emerging best practices for open data services. Next slide. And then in terms of what's next, so looking beyond 2021, already looking further east, so beginning planning and work to expand data services for the Mississippi alluvial plain, expand to include the Apalachicola, Chattahoochee Flint River Basin, and then potentially some pilot activities in Brazil, Mexico, and India as we think about global expansion. There are some key challenges in some of those regions to solve around cloud cover. So we do need at least a few cloud-free observations from the satellite per month, a minimum of one. And there are some places where we won't get that internationally. So we have some additional work to do to leverage satellite observations at different spatial scales to be able to accurately map evapotranspiration. Also working on additional applications and use cases. We know that there are applications for forestry management, anticipating wildfire risk, expanding use for emerging water accounting and trading platforms across the West and potentially into the Southeast. Building out tools and integration with existing applications to support irrigation scheduling and farm management applications. And then also working with our state and federal water management partners on integration into their existing water data information systems. And then we know that there's going to be things that come up as folks look at the data. There might be cases where a model has a problem or the ensemble value strays from what we're expecting. So we anticipate continuing to support research and improvement in the underlying models and the underlying science. And then something we're constantly asked about is, can we apply, will OpenET work for urban areas? And we have some ideas on how to do this. We know we can already measure ET from large parks, open spaces, golf courses, but getting down to even finer spatial scales, there's some additional work that we'll need to do to support that. And then, of course, there's also adding more data summaries for different regions. We've started with irrigated agricultural lands, with croplands. And then we've also had questions about expanding pre-computed summaries for wetlands, various watershed boundaries, state and county boundaries, et cetera. Next slide. So we'll stop there. I think the next thing we wanted to do was to provide a short demo of OpenET, but I'll pause really quick to see if there are a couple of quick clarifying questions, and then we'll show you what this is all about, and then open it up for broader questions. Any one or two quick clarifying questions before we move on to the demo?
Forrest, there was a question that went into the chat. Yeah, exactly, on time series. Just wondering.
Yeah, so currently data will be available through the Data Explorer for 2016 through present at the time of launch. So we'll have that 5-year baseline record plus the current year. Once we complete the accuracy assessment and intercomparison study, we will also begin working on extending that data record back We can go all the way back to 1984 with the Landsat data record. We probably won't have data all the way back to 1984 ready by July, but we will continue to add information working back from 2015 throughout the rest of this year. So, but eventually all the way back to 1984, start of the Landsat data record. Okay, any other quick questions? All right, let me go ahead and share my screen. All right, so this full screen. All right, so what you're looking at is the OpenET Data Explorer. Again, this will be one of just 3 ways that folks can access the information, the other being the API and the custom reporting tools that we're currently developing. First thing I want to point out here is that OpenET does provide information at the original satellite resolution of 30 meters by 30 meters, or about a quarter acre per pixel across the Western US. And then we pre-computed summaries for millions of agricultural fields across the West using publicly available field boundary data sets from state and federal agencies. Of course, I'll zoom in on California first. A few things I want to point out are that the colors here correspond to evapotranspiration as a depth of water in inches. So this color ramp is going to range from 0 up to about 48 inches. 4 acre feet per acre. Information is a bit, we can turn on labels to assist with navigation, toggle back and forth between millimeters and inches, and select different years. We do have data now through 2020 that's under review, actually through last month. The team is currently reviewing that before adding that to the Data Explorer. And I should also mention that in addition to the 11 states, which is just showing, we've gone ahead and now pre-computed the data summaries for the Dakotas through Texas. That data is under review, and again, will be added to the Data Explorer here in just another couple of weeks. So we do have data available now for the 17 Western states. Go ahead and start by zooming in near Rosedale, Rio Bravo, where we've been working with the Rosedale, Rio Bravo Water Storage District on integration of data from OpenET into their water accounting platforms to support implementation of their groundwater sustainability plan. And what you'll notice now is that just by placing my cursor over the field, I can get the time series for monthly ET for that location, the total annually ET for the year selected, and then the crop type and size of the field. Those are just available as diagnostics, and again, they are coming from publicly available sources, so they may not be perfectly up to date, and for some regions, they may differ from what's actually happening on the ground. I'll go ahead and now let's pick one of these fields. When I click on a field, now it's making a call to our geodatabase and pulling back the time series of monthly ET in real time. And this is a field that was probably planted in 2015, is my guess. We're probably looking, this is an almond orchard. Here's the first leaf, second leaf, third leaf, fourth leaf. So as it matures, we're actually tracking the increase in evapotranspiration from that orchard as the canopy develops. Information, again, each of these data points represents the monthly ET as a depth of water in inches, and that's just about exactly what I would expect for fourth leaf almond orchard, around 7 inches peak ET in July. And that's pretty much what I would expect. Information is available for that ensemble value. You can also see the range across the different individual models. And if there's an individual or organization, an agency that's been working with a particular model, can also conduct comparisons across different data sources, see how different models compare. And we can look not only at the monthly time series, but also those cumulative totals. So again, tracking that change as the orchard matures. And what's powerful about this is that as opposed to just using a crop coefficient approach, where it's a lot harder to account for variations in planting configuration, the age of an orchard, local variability in the crop condition. This is giving us a satellite-based measurement based on physical measurements of the land surface to calculate evapotranspiration. Data can also be downloaded as either an image of the graph or as a CSV, XLS, and then the API also supports JSON and GeoJSON formats. Information, again, is available not just for the individual field boundaries, but wall to wall. So if there's a location that's not covered by one of our field boundaries, location, say for a rangeland, pasture, or if someone wants to get a summary for a subset of the field, this data can also be queried directly. This is actually now going out and making a call to Earth Engine, searching through the terabytes and terabytes of data to find this particular location in the map and then extracting a time series. First time I saw how quickly this came back, I was absolutely blown away. We're lucky to have a phenomenal software engineering team working with us, both from DRI and Cal State Monterey Bay and working with Habitat 7. Really wonderful, fun group of people to work with. They've done a phenomenal job, I think, in building a really high performance system for managing what's now, I think we're getting up to 20 billion data points in the database. By the time we're done, we'll have well over 100 billion data points in our geo database. Information, we can also sort of toggle back and forth and look at changes across the landscape for different years. For Rosedale, Rio Bravo, they're already pulling data from the OpenET API into their water accounting system and starting to share that information with growers. In the future, that could become the basis for a water trading platform. So folks who need additional water would have the opportunity to trade with growers, such as someone who might have a younger orchard, have extra water, not need as much for irrigation in that particular year. They may be able to share that water through a water market with other producers in the basin. I'll also hop up to Oakley, California, to the California Delta to show another example. Here we've been, another one of our use cases, we've been really lucky to work with Delta Measurement Consortium on developing applications of OpenET to support the alternative plan of compliance for SB 88. SB 88, of course, required monitoring for all points of diversion in the Delta, all diversions of more than 10 acre-feet per year, as well as monitoring of return flows. The Delta is really complex hydrologically. Monitoring all of these points of diversion and return flows was looking to be pretty expensive. So we've been working with the Delta Watermaster and the Delta Measurement Consortium to propose the use of OpenET now as the basis for the alternative plan of compliance. This would allow OpenET to be used as a rebuttable number, a rebuttable estimate of total consumptive use for a parcel. Here we'll pick this alfalfa field. This would allow a grower to take a look at the ET for that parcel, take a look, say, yeah, 2019, 43 inches, that's about right for what I did for that alfalfa crop. That makes sense to me. Go ahead and download this data or submit it to the agency, and that will be used as my report. Alternatively, they could take a look and say, you know what, something went wrong in 2019. I think I'm probably much closer to 3 acre-feet per acre. That makes a lot more sense to me. And then they may have additional documentation, local measurements or observations that they could submit instead. So I think this ability to allow the grower and the administrator of a program or a state regulator to be looking at the same information using data from OpenET as a rebuttable estimate is a really powerful application. And I think something that can improve coordination and collaboration to address longstanding water management challenges. I want to hop over to look at one other location outside of the state. We'll go look at Grand Valley, Colorado. And this is a location, this is one of the regions that where growers were enrolled in some voluntary conservation programs, incentive-driven conservation programs. This particular field is a roughly 100-acre grass pasture, 2009 ET, right around 38 inches, 3 acre-feet per acre, pretty much what I would expect for a field like this in this location. And when I look at the monthly time series, You see something was clearly different in 2017 and even 2018. When we look at the cumulative totals, the annual totals, that really shows up clearly. 2016, 2019, right around 3 acre-feet per acre, 34 to 38 inches. 2017, they were enrolled in a voluntary conservation program. No water was applied. But of course, there was evapotranspiration from rainfall, and the satellites measured that at just over an acre-foot per acre. But we still see, with just a few clicks here, that there were nearly 2 acre-feet per acre of water savings.
Forrest, we did get one question. Can we track the ET of applied water via this platform? And since you're sort of mentioning precip now, this might be a good place to answer that question.
Thanks, Robin. Yeah, let me answer that in just a moment. And then even more powerfully in 2017, they still went ahead and, or sorry, 2018, still went ahead and applied water, but they put the water on late. So they were still able to produce a harvestable crop, but did deficit irrigate at the beginning of the season, gave up a cutting from that pasture early on. And so as a result, you were able, this producer was able to still produce a crop, but conserve about an acre-foot per acre. And I think accurately assessing those types of deficit irrigation conservation practices is really difficult to do without a tool like OpenET. And again, letting the grower look at the same information that the program administrator is seeing, I think can improve collaboration and cooperation on implementation of these types of programs and reduce some key barriers and costs that have prevented been a barrier to scalability of these types of incentive-driven or voluntary conservation programs. Now, to the question about can we separate ET from precipitation from ET from applied water? Yes, we will be able to do that. At present, what's being shown is the evapotranspiration from all sources, ET from precipitation, ET from applications from surface water and groundwater. We are working on an extension of some of the current data products to be able to separate the ET from applied water and pull out the ET from the effective precipitation. It probably will be something that'll be added, that will be added after the launch in July, but that is something that will be added in the future, along with daily data products. So what I'm showing here currently is the monthly data products. We will be adding the daily data products. Worth mentioning that we do include additional variables as diagnostics, including the reference ET and NDVI. So NDVI, this key measure of crop canopy development. Reference ET is coming from Spatial SIMIS, the California Department of Water Resources, California Irrigation Management Information System in California, and from GridNet for the other 16 Western states. I'll stop there. Happy to look at other locations that might be of interest and answer additional questions. Thanks so much.
Forrest, there was one question about looking at an almond orchard in Madera County and one other location. So before you go too far away from the demo, and then Tara and Christina, I'll stop and you guys can direct questions our way.
That's great. Thank you, Robin and Forrest. And just before we transition over to questions, just a huge thank you to both Robin and Forrest for the presentation, all the great information. It's such an exciting project. And I think, you know, the recognition that putting high quality, trusted water data into the hands of individuals and managers would result in better management outcomes, as well as sort of this role of collaboration in integrating what was, you know, multiple different data sets to provide an ensemble that ultimately results in more accurate estimates, I think is just really exciting and really speaks to a lot of the work that we're excited to see happening in water management and making data available, the power of making data available. So thank you so much. Yeah, with that, I think we can transition to some of the questions that have been asked. One was from Steve, who asked exactly what would an almond orchard in Madera County look like from year to year? And similarly, a field, for example, in Salinas Valley. And so.
Yeah, so maybe while we have, Forrest, if you want to pull the screen share back up and if people have certain locations that they want to check out, we can cover those first, so you don't have to keep going back and forth.
Sure thing. Sorry, this school district is calling here with updates. Apologies if the phone is ringing in the background. Sorry about that. Okay, so let's go look for some almond orchards. I'm going to pick one at random. If there's a particular location or address, let me know. Again, apologies about the phone ringing in the background. So we're seeing about, for a number of these almond orchards, something in the range of probably 52, maybe up to 74 inches at the upper end of the range. Pick one here. So looking at the cumulative totals, again, pretty consistent here. 52 to 56. Let's try another one. What are we seeing there? 51, 52. What else? 52. Sorry, I think I must have said 60 or 70. I think I was looking at the acre line there. So pretty consistently, sort of around 4 to 4.5 acre feet per acre is what we're seeing. And again, these values are going to change slightly once we, at this point, this is just calculated as the ensemble mean. We know one or two of the models had some systematic errors. So if those are not addressed, those will be removed from the ensemble and the ensemble value will be adjusted, but don't expect any major changes here once we get the results of the phase 2. So pretty consistently in the range of about 48 to up to 54 inches. Madeira, if we want to go look at some fields, you said Salinas?
Yeah, truck crops, he said.
Truck crops.
Probably also worth mentioning, Forrest is doing the translation in his head, but we will also have a toggle for acre feet for those folks who are more used to viewing the data that way.
Yeah, that's already working on staging on our staging server. We have not pushed that out to production. So a lot of these, let's see. So there's a lettuce field, about 30 inches. Right. So for some of the leafy greens, probably there's some lettuce broccoli rotation in a lot of these fields. In the range of 30 to 34 inches, 2.5 to 3 acre feet. That's probably, that would match. We've reflected flux tower measurements at some of these sites. We have a celery field that we instrumented last year that was right in that range. Another field, what are we seeing? Similar range, yeah, 28, 29, 30 inches, 2.5 acre feet per acre. It's match. It would definitely match what we were seeing at the celery field. There's something where there's some broccoli produced. That again, pretty consistent. These fields are all perfectly laser leveled, really consistent. As anyone who's driven through this area on Highway 101 knows, I mean, really a beautiful, almost manicured agricultural landscape. Pretty impressive operations. And was there a third location? Any other places folks wanted to go poke around at?
And if people want to find locations after some of the other questions get answered, we can always pull it back up after we go back and forth with some of the Q&A. But thanks so much for taking the time to hone into locations for us. So transitioning to our next question, which comes from Jay Lund, who gives nice accolades to the project. And his comment, I don't know if anyone wants to make a further comment on it, ask about eventually having statistics and error analysis on performance that would make this platform very useful for regulatory and operational water accounting. So I don't know if Robin or Forrest, if you have any thoughts on that.
Yes, so Jay showed you just sort of a preview of a high-level summary of the types of accuracy metrics and statistics that will all be published as part of the OpenET documentation, working on ways to add some of those high-level summary metrics into the metadata. And how many thousands of graphs and diagnostic charts would you like at this point? I think is the only question. So we're working hard to try to find that sweet spot, a manageable level of information that can be easily interpreted and used in the context of management, whether that's irrigator making decisions at the field scale and having to account for uncertainty at the daily time step, to someone sort of tracking an entire basin and wanting to know what the expected error or uncertainty is at a seasonal to annual time step. So yes, So far, we're focusing primarily on measures of slope, mean bias error, mean absolute error, and root mean square error as measures of overall absolute accuracy, and then R squared as a measure of the extent to which we can capture the variability. The models are capturing the variability in our observational data sets. And then we're also working on expanding that to look at watershed scale, water balance analyses using data from USGS.
Very good, thanks.
Great, thank you. We have another question from Enudeep, and she's asking whether there'd be a feature for aggregation across of average ET across a period of time or region, and whether there's the ability to do that.
Yeah, there's two sets of tools we're developing. One, the ability just on that Data Explorer, the interface to just draw a little polygon and get a quick summary. So that's almost ready to roll out to this interface. And then we'll also have the application programming interface to make that really easy to do and to automate via scripts and to get routine updates. And then for folks that are not as comfortable scripting, we're using APIs, we're creating the custom reporting tools. So a user could upload a shapefile, a ranch map, any area of interest. Say I'd like this ET data from this area or from these models summarized on a monthly, quarterly, annual time step, and then it will generate those reports and continue to provide updates at whatever interval the user requests. So that'll be coming along this fall. At least that's my best estimate. As folks can I hope understand, trying to manage a team of 40 scientists and software engineers remotely for getting close to, well, over a year now. Sometimes it's hard to accurately estimate software engineering schedules, but so far the team, I think, has done an absolutely amazing job of staying pretty close to on schedule. Urban landscapes, yes. So already, I'll go back to, well, I'll go back to the screen share in a moment. Already, we know we can get ET for the larger urban landscapes, large parks. We've got data for, and that should be reasonably accurate. Spatial resolution of the data is 30 meters by 30 meters. A key input is that 100-meter resolution Landsat data, so basically 1 hectare. So things that are a lot smaller than that, say individual front yards, lawns, things like that, we're going to have a lot of mixing with rooftops, with roads, driveways, and that'll be a little bit difficult to untangle. So we'll need to work on some additional techniques for smaller vegetated areas and in urban landscapes. That's something that's come up repeatedly, but I think the tool already should be useful for some of the larger parks and should provide reasonably accurate data. One key challenge is we have very few measurements from flux towers or other sources of evapotranspiration from urban vegetation. So it's hard for us to definitively say what our accuracy is because there are so few measurements to compare against. So we might not be able to provide the same level of accuracy characterization for urban environments that we are working on for agricultural landscapes and natural landscapes.
Perfect. Thank you so much, Forrest. And then we have another question. Robin answered it in the chat, but I'll ask it live, and then I'll ask maybe to expand upon it a little bit. And so the question asked about the API and if that would be launched in July as well. And so I'm wondering if you can talk just a little bit more about the launch, what will be available when. And there's also a question that asks about, data limits. Are there going to be limitations in how much data people can get at one time, or if you have any thoughts around that?
And just sorry to cut you off, Forrest. We'll make this the last question, and then we'll sort of finish this sort of more formal portion of the presentation off. I know that Forrest has a hard stop at 1 p.m., so he's going to drop off, but Robin has graciously agreed to stay on until 1:30, so we'll have some time for additional Q&A after that.
Yeah, I'll try to join for the first 5 or 10 minutes or so, Tara, and then we'll need to hop over to the other call. So,
okay.
Steve, let me answer these other questions, then I'll try to hop over. Would you mind putting that in decimal degrees if you have that handy? Happy to jump over to that location. Decimal degrees would be a little bit easier for me to put into the search interface. let's see. So, okay, API, Robin answered that. Should be available probably a couple months after the public launch in July. We are already, though, we have an API working group. Folks are starting to test that. So if there's an application relevant to one of our use cases, please get in touch with Robin and myself. And as soon as the API is ready for additional testing by our partners, we'll let you know. You will need to log in to view the data. Google has graciously contributed the computing resources in kind. We still need to be respectful of other users of Google Earth Engine. So we will ask folks to log in to make sure we can monitor and prevent any accidental or intentional abuse of the data services. The API we anticipate that there will be a generous free tier. We really want folks who need this information to be able to access it and use it, especially local agencies, family farms. We really want to ensure the data is freely available. Of course, that does depend on us receiving support from our current partners, public partners, long term. And there are limits as to how much free data we can provide. So that free tier will have upper limits, and then folks that need lots and lots of data over large areas continuously, say large commercial organizations, folks who are redistributing data to thousands and thousands of users. As part of our long-term sustainability and recharge strategy, we will be working with them to secure recharge to help the project continue to improve the data services that we're providing. Did I miss anything from that?
Oh, that was great. Thank you so much. And perfect timing, I will say also. So thank you to everyone who was able to join. We're obviously happy to have you all stay and ask additional questions for the next half hour or so. I do want to put a plug in for our next Data for Lunch, which is, as I mentioned, scheduled for May 21st, exact same time frame, noon to 1 for the main portion of the presentation, and then some informal discussion thereafter. Amanda has put the registration link into the chat, so feel free to grab it there, or you can also grab it on the consortium's website at cawaterdata.org. So thank you all for joining us, and we are going to go ahead, and you can now unmute yourself if you have questions, but we'll also work through the questions that have been dropped into the chat as well. So,
Forrest, too, before you leave, there's one that I don't know the answer to, so I just want to make sure to ask it while you're still here, which is the 30-meter data on the USGS ARD grid?
We are using, we reprojected everything to use MGRS tiles. So we're using MGRS. That should match that should match the ARD grid, because the ARD grid was the basis for the harmonized Landsat Sentinel data, which used the MGRS tiling scheme. So I am 95% sure the answer to that is yes. I would need to double check.
Thanks.
And then there was a question about what are the best ways for private field scale data system providers to engage with the consortium. That for OpenET, that's why we've developed we are developing the custom reporting tools. We know that there's going to be folks that have data that they want to use to compute summaries, and that they will not want to share that with the public. So that's the whole purpose of the custom reporting tools, to allow someone to upload, again, a range map, other ancillary information that will only be available to that user. And we can go ahead and use it to compute summaries from OpenET. There's other applications like with the Delta Water Master and the Central and South Delta Water Agencies, where they would want to create a publicly available interface to show custom summaries and let all users in the Delta see those summaries. So we can also create localized implementations of OpenET for places like the Delta. So we will also support those use cases. Hope that answers that question. And then Steve, I noticed I think in your earlier question, I only saw the latitude. I think the latitude was accidentally.
He dropped off. I think he had to run anyway.
Okay, well, I'll follow up with Steve about that.
There is a question about being able to sort of query according to crop type. And we're still sort of working out what types of queries we would build into the custom reporting interface, but I don't think that's one that's been prioritized. But Forrest, I don't know if you have a different take on that.
There is an option in the API to specify a crop type. I will say the crop type information is, again, based on publicly available sources, just providing it as a diagnostic to help folks understand, why is it, why am I seeing 50 inches of ET here and 30 inches of ET here? And if you understand one's a perennial crop and one's an annual crop, that makes a lot more sense, right? So we're just providing it as a diagnostic. I will say the data from Land IQ and Department of Water Resources for 2016, we're using that for 2016 for California. I'm pretty impressed by it. Not perfect, but pretty impressive. Data from 2019 is from the Cropland data layer, a lot more inconsistency. So the crop type information is best available information from publicly available sources and only provided as a diagnostic. So for that type of analysis, we would hope that the user would have their own polygons, their own crop type information that they could use to compute summaries. And folks can use raster masks through the API, so you can both upload a shapefile or develop a raster mask that could be used to compute summaries from the gridded ET data.
Perfect. And I'm not seeing more questions in the chat, so I'm going to go ahead and take this opportunity to pose a question to Tara. And I'm curious, Tara, if you can talk a little bit more about the consortium's role in working with OpenET and highlight any specific projects or perspectives.
Sure, happy to. Yeah, so we have the good fortune of working with OpenET on a couple of different projects. One is a relatively new partnership with EDF on their water accounting and trading platform, which integrates OpenET into their estimates of water use in Rosedale Rio Bravo. So that's a water platform that was developed to really serve as this accounting tool, was developed in partnership with Rosedale Rio Bravo. And I think really has a lot of potential as we think about how we can take that platform and scale it and make it available more broadly. The other one we heard Forrest talk about is a partnership that OpenET has with the Delta Measurement Experimentation Consortium. And we've been working with them, supporting some of the software development as they have been using OpenET, as Forrest mentioned, to achieve their alternative compliance plan there. And we really see this as a huge opportunity to improve both the accuracy of estimates of water use in the Delta and ensure that diverters are able to report that data to the state in a timely and accurate manner. And then to similarly use that information to think about how do we ensure that we are using that information to then understand other factors that are affecting water use and diversions in the Delta moving forward and improve those estimates through time. So two really exciting projects where there's a partnership with OpenET. And I think as both Forrest and Robin laid out, there are just a whole host of other applications that I think are really being teed up because of the data, the high quality data that is being provided. So lots of exciting opportunities moving forward as well.
Perfect. Thank you, Tara.
Thanks, Christina.
And I think others, we've transitioned to the phase of the discussion where if you have questions, you can come off of mute and ask those questions. So we'll leave space for that as well.
I do also really want to acknowledge Christina and Eric Averitt for being such phenomenal partners on the use case in Rosedale Rio Bravo. So none of that would be possible without their contributions, of course.
It's been a lot of fun, and we're excited to see where it all continues to go. So thank you.
And if anyone is unhappy with OpenET, it's all Joya Banerjee's fault for bringing together folks at a workshop at NASA Ames five years ago. So
are you going to unmute yourself for that, Joya?
Defend my honor here. No, it's just to say that, you know, the SD Bechtel Junior Foundation has since closed its doors, but it was a true privilege to get to work with OpenET and get to support this incredible collaboration, and then to do the same with the consortium. And so it's just seeing it, this is like a wonderful moment of getting to see two phenomenal projects collaborate and do some great work for the state of California and beyond.
And more seriously, I really do want to acknowledge Joya for having the vision and being willing to support the project and team, and really being a champion early on at a time when this was just, you know, just a possibility. So the vision Joya had and the team she brought together was really what made this all possible. So thank you, Joya.
I just can't wait for a moment where we can all be in a workshop together again.
I'm curious, as we hear from any water managers that are out there, if you know how you intend to use this. We've heard a bunch of the use cases already, and we had some really great questions. But are there other ways that people are thinking about this, or would love to hear your guys' thoughts if anyone wants to ask questions around that, or is thinking about how they want to access the data moving forward.
There is one question for us about API documentation that you could answer.
We are just finishing the integration of the user authentication functionality with the API documentation. That's required some rewrite of the documentation. We have a draft complete. Please reach out to Robin or to myself, and we can add you to the API working group. So especially, we are looking at additional, I think we'd love to have feedback from folks that are working on use cases related to management of forests, rangelands, other natural landscapes. So John, please reach out to me and Robin.
Thanks. I just came off mute because it's quiet here, I hope. But yeah, actually we're trying to compare different data sets. And so we have a whole bunch of other data, and thinking about trying to pull in the data and the historical data primarily at this point. So I have some people working on regression analysis between other satellite data and fire activity, and would like to know what the ET was just before that. So
yeah, we do have a use case partnership with Salt River Project in Arizona, where they're interested in looking at changes in ET, sort of looking at before and after different treatment approaches for forest management. So a similar or at least connected application there.
Great. So yeah, I'll email you guys. Thank you.
Yeah.
So if there aren't any other questions, we may close out for the afternoon and give people their time back.
Tara, could I ask one quick question?
Of course.
Yeah, just building on the last comment, I was curious if you could touch on the potential to look at non-field boundaries. So for example, wetlands, either managed or natural, or areas that are not currently delineated by field boundaries, including perhaps even open water in some areas.
Yes, so again, the data products are at that 30 meter by 30 meter, roughly quarter acre per pixel resolution. They're available. That will be supported both through the custom reporting tools, the API, and then through the Data Explorer, we'll be adding some tools to let users draw boundaries on the map and get summaries straight from the data interface. If you have recommendations for one or two sets of boundaries for riparian areas or wetlands that you think would be extremely useful to a large number of users, please let us know. We can add additional pre-computed summaries, but we want to ensure that we're selecting the right boundaries. And then open water, we will provide estimates initially. We're working on a solution specifically for open water. And we know that there are some special use cases, especially for larger water bodies. That's something that is of strong interest to our many partners, including those at US Bureau of Reclamation, Texas Water Development Board, and a number of other partners. So the data will be there for open water at the time of launch. Treat it with a little bit more caution initially, and then we'll have a solution specifically for open water, hopefully by the end of the year, maybe early next year. And we will provide a best practices document close to the time of launch that will describe some of these specific applications and our recommendations for use. Yeah, and then I don't think I didn't put my email address there. So Martha, I'll put that in the chat.
I'll put mine in as well, and folks are welcome to email me with questions.
Thank you. And then I can follow up with you with some of the people that are working as leads in those areas.
Any last technical questions? And then I probably need to sign off here. We'll really appreciate everyone's time. Thank you again. Tara, thank you to the California Water Data Consortium, Christina. Big thanks again to Joya Banerjee for having the vision initially and being such a good supporter and strong champion for this effort. Thank you all for joining and for your time. Really enjoyed talking with you.
A huge thank you, Forrest and Robin, for the presentation and for being here. And I think with that, we'll go ahead and close. So yeah,